This is continuing section 1.2. So we were talking about Cartesian coordinates, and now let's talk about Cartesian products. We've seen pairs. We can also have n tuple, which is however many we need. And again, we say ordered because the order matters. So the ordered n tuple is x1, x2, all the way up to xn. And again, in order for two of them to be equal, each element of all of them in order have to be equal. So is 1, 2, 3, 4 equal to 1, 2, 4, 3? No, it's definitely not, because all of them need to be equal and in the same order, and that is not the case. However, if we have 3, comma negative 2 quantity squared, comma 1/2, that is equal to root 9, comma 4, comma 3 over 6. Again, those are different ways of expressing the same thing, so we would say they are equal to each other. All right, let's now look at a Cartesian product. And we are going to put this little X symbol, and we generally read that as cross, so that we make sure that we are not talking about multiplication, because that is different. So if we have A1 cross A2 cross all the way up to A sub n, that is a Cartesian product. And we would say then that we've got those ordered pairs then, A1, A2, all the way up to AN, where we would understand that the first element, little a1, is in the first set, big A1. The second element, A2, is in the set A2, and so on, all the way up to the element A sub n is in the set A sub n. And again, that cross of just 2 is definitely going to be the most common. So let's find some Cartesian products. So here A is x and y, B is 1, 2, and 3, and C is A and B. So let's start by finding A cross B. So again, that means the A elements are going to come first, the B elements are going to come second, and I am going to use all of them. So I'll have x comma 1, y comma 1, x comma 2, y comma 2, and then x comma 3, y comma 3. As we want to be careful, the order matters. So if I have B cross A, I'm still using all of B and all of A, but now the B values come first. So 1 comma x, 1 comma y, 2 comma x, 2 comma y, and 3 comma x, 3 comma y. We can take a set cross itself, so A cross A, and that would be x comma x, x comma y comma x, and y comma y. How many elements then were in each of those first 3 cross? And again, we've got them listed so we can read them pretty easily. So A cross B and B cross A both had 6, and you'll notice that is the number of elements in B times the number of elements in A. And then A cross A had 4 elements. We can take a cross with a cross. And as with other math, we'll do the parentheses first. So parentheses first, A cross B, and then we will cross that with C. We already have that A cross B, so I will use that as a reference. And as you can see, we've got quite a few values here, and we've also got parentheses inside parentheses. So I've got x comma 1 in parentheses, and then comma A in parentheses, and then x comma 2 in parentheses, comma A, x comma 3 in parentheses, comma A, and as you can see, we will then have that for the next few values as well. So it does look a little bit strange, but that is how we are going to express that. And where's my next question? So now let's do A cross B cross C, where now you'll notice there are no parentheses. We've just got those 3 things with the cross. So it's pretty similar to what we just had, but you'll notice we don't have parentheses inside parentheses, as we did for this one. So I still have x comma 1 comma A, x comma 2 comma A, x comma 3 comma A, but again, I don't have those parentheses within parentheses. And that's the big difference we want to notice there. Our final question, remember capital R, that's a set of all real numbers. So what is R cross R? And we would say that is the set of all ordered pairs x comma y where we have our Cartesian coordinate plane. And in fact, that R cross R is usually described as that Cartesian coordinate plane, which we are all hopefully fairly familiar with. And that is now everything in section 1.0.